source and 10 ohms as resistance, and I am not fixing the RL. I am not fixing the RL value. Let RL be varied from, let us take RL is equal to 1 ohm. Okay. Okay, let us take 1 ohm. So if RL is equal to 1 ohm, so what is the current that is flowing in this circuit? I is equal to V by 10 by 10 plus 1. How much? 11. How much is the value? When RL is equal to 1 ohm, what is I1? I1 is equal to 10 by 11. How much is the answer?
0.90.
0.90.
90.
Okay. When RL is equal to 2 ohms, so what could be the answer? When I will be that means 10 by 12. How much? What is the value? 0.8. When RL is equal to 3 ohms, what is the answer? 10 by 13. How much?
0.7.
0.7. Similarly, when I is equal to 5 ohms, when RL is equal to 5 ohms, what is the I? 10 by
0.6.
5.
0.5.
10 by 0.5. Okay. These are all amperes. So amperes. Don't forget to write this A. Okay. When it is 8 ohms, can you tell me the answer? I 8 ohms is equal to, so 10 by 10 plus 8, 18. This is 15. What is 10 by 15?
0.6, sir.
0.6. Okay. What is 10 by 18?
0.55.
0.55, sir.
0.55.
55.
Okay. Okay. Now 10 ohms. I 10 ohms is equal to how much? 10 divided by 20. 1 by 2, that is 0.5 amperes. Okay, 0.5 amperes. When I is equal to 12 ohms, when RL is equal to 12 ohms, what is the answer? So 10 divided by 22, how much?
0.45.
0.4 amperes. When it is 15, can you tell me the answer? I 15 ohms.
0.4, sir.
10 divided by 15, 25.
0.4, sir.
మరి 0.4 వచ్చినాయా 10 by 22. What is
10 by 22, 0.45, sir.
45. Okay, this is 0.4. Okay, I 19. If it is 19 ohms, so 10 divided by 19 plus 10, 29. How much it is?
0.34.
0.34 amperes. Now, the voltage drop across this resistance V1 ohm is equal to how much? The current 0.9 into the resistance 1. So 0.9 into 1, how much? 0.9 volts. Similarly, the voltage drop in the resistance RL, when 2 ohms is there, then how much is the value? 0.8 into 2, how much? 1.6 volts.
1.6.
Yeah. Similarly, V3 ohms is how much? 0.7 amperes into 3. How much? 2.1 volts.
2.1.
Yeah. Similarly, V5 ohms is equal to 0.6 into 5. That is 3 volts, right?
3 volts.
Yeah. Similarly, V8 ohms is equal to how much? 0.55 into 0.55 into 8. How much? You tell me. Similarly, V10 ohms is
0.4.
equal to how much? 0.55 into 8. So 0.5 into 10. That is 5 volts. How much is this? 0.55 into 8.
4.4 volts, sir.
4.4 volts. Yeah, very good. Similarly, V12. V12 is 0.45 into 12. How much?
5.4 volts.
5.4 volts. So V15, 0.4 into 15. Similarly, 0.34 into 19. You tell these two answers.
Six volts, sir. V15.
Yeah. V19,
0.46, sir.
how much?
6.46, sir.
6.46.
46 volts.
6.46. Am I right? 6.46. Am I right?
Yes, sir.
Now, you tell me P1 or P1 ohm is equal to V into I. That is 0.9 into 0.9. How much? 0.9 into 0.9.
0.8.
0.81.
0.81.
81, sir.
Okay. 0.8 watts. Similarly, tell me P2. P2 ohms is equal to current 0.8 into 1.6. How much?
1.28.
1.28.
1.28
28.
watts. Okay. Similarly, tell me what is P3? P3 is 0.7 into 2.1.
1.4.
1.4 watts.
7.
Similarly, you tell me P5. P5 is 0.6 into V5, 3. How much?
1.8 watts, sir.
1.8 watts. You tell me when it is 8, P8. P8 is 0.55 into 4.4.
2.42 watts. 2.442, sir.
2.42 watts. You tell me what is P10. P10 is 0.5 into 5. That is 2.5 watts. Okay. Similarly, P12. P12 is 0.45 into 5.4.
2.43 volts, sir.
2.43 watts. Okay. Next, you tell me P15. P15 is 0.4 into 6. That is 2.4 watts. You tell me P19. P19 is equal to 0.34 into 6.46.
2.19 watts, sir.
2.2. Okay. 2.2 watts. What we observed from this P1 to P19? What we observed? Can anyone tell me? There is a keen observation when RL is increasing. Okay, when you are increasing the RL value, what is happening to the power? Power is also increasing 0.81, 1.28, 1.4, 1.8. Like that, the power is increasing. And when your RL is equal to, okay, when RL is equal to 10 watts or 10 ohms, okay, you got a maximum power of 2.5 watts, and then there is a decrease in the power, right? So when maximum power is reached, when maximum power is reached, when RL is equal to 10 ohms, that means when this load resistance is equal to 10 ohms, then maximum power is transferred from source to load. How much it is? In this case, it is 2.5 watts. Can you tell me why this happened? So what happened when you are putting 1 ohm, it is 0.81. When you are putting 2 ohms, it is 1.28. Like that, when you increase in the resistance value RL, at one point you are going to get the maximum value. And after beyond 10, that means 11, 12, 13, 14, 18, 19. Okay, you are getting a wattage less than 2.5. You can observe from the numerical values. So what is happening? At one point, you are getting the maximum value. That means maximum power is transferred when, suppose this is the entire source resistance. So this is entire source resistance. Okay, RS. Okay. So when RS is equal to RL or RL is equal to RS, then you are going to get the maximum power transferred from source to load. So this is our maximum power transferred. Maximum power is transferred to the load when the load resistance is equal to Thevenin's resistance seen from the load. Okay. In this case, our resistance is only one resistance. If you have a circuit like this, suppose if you have a circuit like this, okay, some few resistances are there and some voltage source is there. Suppose this is the circuit and this is your RL. Okay, then can you tell me at what resistance? This is 10 ohms, this is 5 ohms, and this is 5 ohms. Okay, suppose if I give a circuit like this, okay, then how you are going to tell at what resistance of RL you get the maximum value? So RL should be equal to what resistance? 5 or 10 or 5? So in order to remove this ambiguity, what we are doing is we are going to reduce this network to a Thevenin's network. What is Thevenin's network? So this entire network, okay, that is seen from this RL can be reduced into a simple network called VTH and RTH. Okay, So this entire network is reduced to VTH and RTH, and now your for you to tell at what resistance of RL you will get the maximum power. At RL is equal to RTH, you are going to get the maximum power. You are going to get the maximum power. Okay. Am I clear up to now? Am I clear up to now? Please respond. Yeah. Now, so here is a small derivation. Okay. So maximum power is transferred. That means, see here, let P is the power that is transferred from VTH to RL. So P is equal to I square into RL. Okay, I square into RL. What is I? I is nothing but, what is I? In this circuit, I is equal to VTH by RTH plus RL. RTH plus RL. So substitute that one here. So VTH by RTH plus RL was square into RL. So for any equation, okay, suppose this is equation 1. This equation will become maximum when you derive this equation and equate it to 0. So what is the varying quantity in this circuit? RL is varying quantity. So differentiate this P with respect to RL, then you will going to get the and equate it to 0. You are going to get the condition for maximum. So maximum condition will come only when you derive the equation and equate it to 0. So in what form it is? It is in the form A by B, right? Okay. So if you can anyone derive this? So what is the VTH by RTH? RTH plus RL whole square into RL into RL. Okay, this is your P. This is your P. Now VTH is constant, so you bring it down common. So dP by DRL is equal to VTH square into, it is in the form of A by B. So B into, that is RTH plus RL whole square into B into derivative of RL with respect to RL is 1 minus RL into 2 into RTH plus RL. Derivation of RTH plus RL whole square. Okay. Divided by RTH plus RL whole square into whole square. So equate it to 0. So denominator goes here and denominator gets cancelled, becomes 0. So VTH square into RTH plus RL whole square. So RTH square plus RL square plus 2 RTH RL, okay, minus 2 RTH RL minus RL square is equal to 0. Okay. So whether VTH will not be equal to 0, so this term should be equal to 0. So this get cancelled. So minus RL square minus 2 RL square here. Okay. So so RTH square plus RL square minus 2 RL square. So minus RL square is equal to 0. So if you bring this to here, so RTH is equal to RL. RTH is equal to RL. This is the condition for maximum efficiency. Okay. Maximum power. So the power will be maximum when RTH is equal to RL. Am I clear up to now?
Yes,
Please
sir.
respond. Am I clear up to now? Yes. So this is the condition which you have derived. Now, now substitute that one in the equation. So what is P? P is equal to VTH square divided by RTH plus RL whole square into RL. The P becomes PM when RTH is equal to RL. So substitute RTH in the place of RL. So RTH plus RTH 4. So instead of RTH, we place RL. So RL plus RL whole square, okay, into RL, that is equal to VTH by 2RL whole square, which is 4RL square. Okay, RL square into RL. Okay, so VTH by 4, 1 RL will get cancelled, 4 RL. Or you can write VTH by 4 RTH, because RTH is equal to RL. So if you want to calculate the maximum power that can be transferred, you can use this equation. So sorry, square will be there, VTH square by 4 RTH. VTH square by 4 RTH. So VTH square by P maximum will be VTH square by 4 RTH. So in the previous example which you have done, so what happened to the maximum power? Maximum power, power has been increased to some maximum value and then decreased. So if you draw the graph, okay, so between power and the load, P and the load are increasing. At one point it reaches maximum and then decreases and then decreases. Then this is called your when RL is equal to RTH. This happens only when RL is equal to RTH, and the maximum power you will get, we can call it as Pmax. So at Pmax, you are going to get RL is equal to RTH. Okay, am I clear up to now? Am I clear up to now? Shall we solve one problem? Find the RL for the circuit shown in the figure. So this is the circuit and he is asking you to find the value of RL for which maximum power is transferred to the load resistance RL. Okay, and he is also asking you to find the maximum power. So to find this RL, I can't say whether it is RL should be equal to 2 ohms, 3 ohms or 6 ohms, because here so many resistances are there. When more than one resistance is there in the circuit, what you have to do, you have to reduce it to a Thevenin equivalent circuit. So first step is to remove the RL between A and B terminals. Remove the RL between A and B terminals and try to find the RTH and VTH. So here it is 12 volts and this is your 6 ohms and this is your 3 ohms and this is your 2 ohms and this is your 2 amperes and this is your 12 ohms, and this is your circuit when RL is removed. Okay, to find RTH, what you have to do? You have to short the 12 volt circuit and you have to open the 2 amperes. So to find RTH, first we will find RTH. So this is 6 ohms, 3 ohms and 12 ohms. 12, 3, 6 and 2. This is how your circuit looks like when you have A and B terminals, and this is 2 ohms. So tell me what is RTH? 2 and 3 are in series, so 2 plus 3 is 5 and 5 is in parallel with 5 is in parallel with, or what you can do is you can or 5 is in series with 6 parallel with 12. 6 parallel with 12 is equal to RTH. Because 6 and 12 are in parallel, so 5 plus 6 into 12 divided by 6 plus 12, 18. That is equal to 9 ohms. So RTH is equal to 9 ohms. When RTH is equal to 9 ohms. Now you want VTH, because if you want to calculate, so what should be the RL? RL should be equal to 9 ohms to get the maximum power. The next step is to find VTH. How to find VTH? So this is your 6 ohms and this is your 12 ohms and this is your, how much is this? 3 and 3 ohms and this is your 2 amperes. Since it is open circuited, no current flows into this circuit, so I is equal to 0, and here 12 volts is there. And how to find this voltage across A and B terminals? It is same as voltage across this 2 ohms or voltage across 12 plus 3. Okay. Now, so it is forming a 2 loops. You tell me what is the equation. Let it be I1, let it be I2. Okay, I2. Okay, and this is plus, this is negative. You tell me the, can anyone tell me the loop equation? So minus 12 plus 6 I1 plus 12 I1 minus I2 is equal to 0. And in this loop, I2 is equal to minus 2 amperes. I2 is equal to minus 2 amperes. So minus 12, substitute I2 here, plus 6 I1 plus 12 into I1 plus 2 is equal to 0. So minus 12 plus 6 I1 plus 12 I1 plus 24 is equal to 0. Okay. So 18 I1 is equal to minus 12. 18 I1 is equal to minus 12. So I1 is equal to minus 12 by 18. So the voltage across this is let V 12 and voltage across this is V3 and voltage across this is VTH. VTH. So V12 plus V3 plus VTH is equal to 0. So in a closed loop, the sum of the voltages is 0. Okay. Now VTH is equal to or minus VTH is equal to V12 plus V 12 into I1 minus I2. What is I1? I1 is minus 12 by 18 minus I2. What is I2? I2 is minus 12 plus so plus 2. Okay. Plus what is V3? V3 is equal to 3 into I2, that is minus 2. So can anyone tell me what is minus VTH is equal to? Can you solve and tell me the answer? What is VTH? Yeah. Anybody solving? Sangeeta, Priya, Srija, Rajesh, 162. Yeah.
Ten, sir.
Yeah. So VTH is equal to, you are getting 10, huh?
Yes, sir.
VTH is equal to 10. So,
Minus 10, sir.
okay, whatever it may be. But you should get
22, sir.
22 you are getting. Yeah. After solving, you are going to get VTH as 22 volts. So, so maximum power is VTH by 4 RTH. So Pmax is equal to VTH, that is 22 square divided by 4 into what is RTH? 9. How much you got? You tell me. You should get 13.44 watts. 13.44 watts. Is it clear up to now?